So we have skipped 5.3. 5.3 is on partial fractions, and it comes in a good location in the chapter, but we don't cover that in this course. If you go on and take calculus, I don't think you need it till second semester of calculus, but they will review it there. And they'll probably review it in pre-calculus as well if you take that course. Okay, so we're on to systems will be in two variables, but they're nonlinear equations. So in 5.1 and 5.2, we were working with linear equations. 5.1, we had two variables. In 5.2, we had three variables. Okay, so that was the difference. So what do we mean by nonlinear equations? Well, we're talking about things, not lines, but we can still have lines, but like a parabola or a circle or some of our other basic functions that we have, like the cubic curve or the cubed root or the square root or things like that. Okay? Now, we're not going to see a lot of different examples probably in this section, but it is something to talk about. We are still in two variables. So you don't have to worry about being in three variables. So we'll be in two variables. And sometimes we will still have a line. Now, when we had in 5.1, when we had like a system of linear equations, we said, oh, you could graph the line and you could graph another line. Not like that's a line. And we said, oh, they cross, they share a point, and that's the point of intersection and what we're looking for. So that was a picture of what we were doing. Now, not all lines crossed. Some were parallel and there was no solution. Sometimes we only had one line and there was an infinite number of solutions. Our methods that we used, though, were substitution and addition methods. We'll still be using those methods. Now, remember, the addition method has to do with eliminating a variable. And so we'll still look at that in some of the problems. Okay, so the best thing to do is jump in and give you an example. So you see that there are two equations and they both have two variables. So this is a system. We're going to say it's a system of nonlinear equations in two variables because the top one is not linear. How do you know? Because it has an x squared in it. And it actually is an equation of a parabola. In fact, I could rewrite that. Let's see. If I write it as 2y equals x squared minus 10. So you can think about that a little bit, like if you got 2y by itself and you subtracted 10, and then if you were to divide by 2, this is one way you could look at this equation, you'd have 1/2 x squared minus 5. Now, if you think about what you know about transformations, this is a parabola, right? But it's only going half the distance, and it's shifted 5 units down. So if we think about what that looks like, let's see, 0, -5, 1, 2, 3, 4, 5. So that would be like the vertex. And then if you were to put in 1, you'd get what, 4.5? It is an even function, so you can put another point over there. And if you put in 2, 2 squared is 4, half of 4 is 2, you get -3. 1, 2, 3. 1, 2, 3. So we get this little parabola that's looking something like this. And that would be that parabola. We could put in some more points, and we might want to. Okay. Now, let's look at this. This is linear. It's a line. So let's go ahead and say 3x minus 9 equals y. So if you do the algebra and you move stuff around, you get something like that. And so we know because it's linear, this is linear. This was quadratic. This was a parabola. And in both of those cases, I was getting y by itself, which is one way you could do this problem. All right. And then I could say minus 9, let's see, is the y-intercept, and it has a slope of 3, so up 1, 2, 3, and over 1. Over 1. 1, 2, 3, over 1. And so this line is going through kind of like that. Okay? All right. So that's great. That's a picture. You can see there's a point that they share right there. Is there another point they share? Well, maybe. Okay, what could we do to solve this then without doing more graph work and stuff like that. Well, we could substitute 3x minus 9 into the other equation. So I would have x squared equals 2 times 3x minus 9 plus 10. That is substitution. So I had this equation with y by itself. And so I said, well, I can plug the 3x minus 9 in for y. Now, why didn't I go to this equation over here? I could have, but I didn't. Okay, so let's see what happens here. X squared equals 6x minus 18 plus 10, or x squared equals 6x minus 8. So if I get everything on one side, it is quadratic. X squared minus 6x plus 8 equals 0. And that's going to factor into x minus 4 and x minus 2. And so I get x equals 4 and 2. Okay, if x is 4, what is y? Well, we can go right back up to this equation that we used to substitute. Y equals 3 times 4 minus 9. So that's going to be 12 minus 9, or 3. One point then of intersection is the point 4, 3. All right, so that would be the point 1, 2, 3, 4, 1, 2, 3. So right here, apparently, if I had kept graphing, I would have seen it going through there, I guess. But I didn't keep graphing. I should have graphed one more point or two more points. Okay, so that's a point that they share in common right here, it looks like about. And then it says the other one is 2. Well, I have to find y. So again, I'm going to use that equation right here. Let's see, 3 times 2 minus 9, which gives me 6 minus 9, or y equals negative 3. So I have another point that they share, 2 comma negative 3. And I believe that's the point we saw right there. Okay, but there were two solutions then for the system. There's the point 4, 3 and the point 2, negative 3. So we kind of showed you a graph of what's going on here. You could graph this better, find more points and stuff. But then we have this line right here that comes from this equation, that line, and it's intersecting, I guess, the parabola in 2 points. Okay, so this is the solution. These are the solutions, those 2 points. Okay. And we did it algebraically with substitution.